Hi, today we're going to be working with identifying linear functions, which is the first part of our unit on linear functions. So when you set up your notebook for today, make sure that you put the unit, which is linear functions, and the title, as well as the date. Take a moment and pause here to make sure that you are writing your objective and vocabulary down. And when you're done pausing, restart. Okay, you're on to the next page. So what you need to do now is make sure that you head on to writing down your notes about graphing linear functions. So if you look at this, you notice that the graph on the right about distance traveled does represent a function. If you remember our vertical line test, every x value has exactly one y value. It's a straight line and thus called a linear function. Before we had different kinds of functions that had one x and one y, but these are linear functions. They make a straight line. So let's take a moment and look at the four different graphs that are shown. So we have this graph here, and this graph does represent a linear function. If you notice, one x is paired with each individual y. What about this graph? This graph here, is this or is this not a linear function? Please, in your notes, write whether this is a linear function. This would be 1. This is 2. This is 3. And this is 4. So take a moment, pause, look at the screen, and decide whether or not these are linear functions. When you restart, we'll go back through them together. Okay, so let's go back through them together. In number 1, again, this is a linear function. It's very similar to the piece up here. Number 2 is not a linear function. It does not pass the vertical line test because it is itself a vertical line. The x value here is -2, but -2 is paired with 0, 1, 2, 3, etc., all the way along this line. So it is not a linear function. If you look at number 3, this is also not a linear function. It does not pass the vertical line test, so it's not even a function. What about number 4? It does pass the vertical line test, but is it a straight line? No. So this is also not a linear function, although it is a function. The only linear function of the 4 is the first one. All right, let's go on to the next slide. Sorry, there you go. Oops, there you go. So now we can decide whether or not an ordered pair satisfies a linear function. And we talked about how to determine if an ordered pair was a function, and if you remember, every x value would be paired with one y value. So now we have to decide if it's a linear function. First of all, you're going to want to decide if it's a function. And if we look at number 1, we have 0, 4, 8, 12, 16. Those are all individual x's. They each are paired to a single y, so it is a function. Now we need to decide, is this change consistent? From 0 to 4 goes up 4, 4 to 8 goes up 4, 8 to 12 goes up 4, 12 to 16 goes up 4. -3 to 0 goes up 3. We go up another 3, another 3, another 3. So this is in fact, yes, a linear function. Let's look at the next one. First, we can determine, is this a function? -4 is paired with -2, 0, 2, and 4. So we have 4 different x values, each paired with their own y value. So from it goes up by, from 4 to -2 goes up +2, +2, +2, +2. On the y values, we go down 12. Do we go down 12 again here? No. Down 12 here? No. Down 12 here? No. So this is not a linear function. And our final one, 3, 5, 7, 9, 11, that goes up 2 each time. 5, 4, 3, 2, 1 goes down 1 each time in the y. this is a linear function. Again, let's look at what that looks like. If I take from here to here, that goes up 2. So I can say that's plus 2. From here to here, plus 2, plus 2, plus 2. From here to here, minus 1, minus 1, minus 1, minus 1. Take a second and pause so you can write some notes. And when you join us, we will start with the new. Another way to determine whether a function is linear is to look at the equation itself. A function is linear if it is described by a linear equation. And a linear equation is any equation that can be written in the standard form shown below. So if you notice, this is the standard form of a linear equation. What I recommend is you pause, print out this page, and then we're going to glue this in your notebook and we'll discuss it. Okay, so now that you've got that glued into your notebook, if you notice the standard form of the linear equation here, and you look at what it has, ax, it's got the single x, it's got a y, and its c is really like a constant. Ax plus by equals c. That's the standard form of the equation. It's written where the x and y have either an exponent of 1, so there has to be both an x and a y. It has a constant, but it can be written without the constant because if 0 is the constant, if you notice down here, 5x plus y equals 0 can also be written as negative y equals 5x if you just move the y to the other side, if you subtract y from both sides. Also notice that these are not linear equations. We've got an x and y together multiplied. Here we have an exponent. Here we have y in the denominator. None of these are going to be linear equations. If I tried to simplify this so y is not in the denominator, I'm going to end up getting an x times a y. So that's why that doesn't work. All right. So if we know that that's a way to find it with an equation, I can look at this equation here and decide whether or not it is a linear function. So what you're going to do is pause, decide whether or not this is a linear function, draw the graph, and we'll go through it. Okay, welcome back. X equals 2y plus 4. That can be rewritten as, here, let's go through. If we subtract 2y from both sides, we are going to get x minus 2y equals 4. And this is in standard form. I can even rewrite this as plus negative 2y equals 4. So this is in fact standard form. Now, how do you graph something like this? Well, just like when we were working with functions, if you're not given a domain, you can choose your own. You can rewrite this as y, negative 2y equals negative x plus 4. I did that by subtracting x from both sides here. And then if I do that, I'm going to divide both sides by negative 2, divide by negative 2 on both sides. And I have y equals 1/2 x plus negative 2. And if you want to pause for a second to make sure you understand how that dividing by 2 works, please do. And if you have a question about it later, please make sure you ask in class. So once you have this, you can go ahead and substitute values for x and graph. Is this a linear function? Take a moment, pause, decide whether it is, and if so, I want you to graph the function. Okay, welcome back. X times y here. This is not a linear function. If you look back on your notes down here, You cannot have an x and y multiplied together. They cannot be multiplied together if it's a linear function. So this is not a linear function. I can draw a big red line through this. This is not a linear function. Not going to work. Okay, my next one, is this a linear function? Well, y equals 5x minus 9. I have a single y, I have a single x, and a constant. Pause for a moment and decide whether or not this is a linear function. And please graph it if it is. Yes, you're right. This is a linear function. Again, y minus 5x, or I could say negative 5x plus y equals negative 9. And this one's nice and easy to graph because I've already gotten it here in y equals, and then the x and the constant on this side. I can substitute values for x and go ahead and find my y values. Now let's talk about how this works with a word problem. If you look here, this is actually y equals 7x. This is a linear function. And it's an approximate relationship between human years and dog years given by this function. And x is the number of human years. And they say, when a dog ages every 7 years for a human year. Why would you graph this in the single quadrant only? Please write this down in your notes, why this would be graphed in the single quadrant only. If you said it's because years can't be negative and people don't age backwards, that is absolutely true. So in this case, we would want to put years, maybe the human years here, right? Because that's x. Dog years would go here, that's our y, and we would graph starting at 0 and up to this direction. So our line is going to look something like starting at 0, 0, going this direction. And make sure you put a line, an arrow on the end, although clearly no one lives forever. We're going to graph it with an arrow on the end showing that it does continue past our current graph. Let's try another one. The cost of a can of iced tea mix at Save More Grocery is $4.75. The function f of x equals 4.75x gives the cost of x cans of iced tea mix, which means that when I substitute an x value here, the outcome, or my function of x equals y here, tells me the amount. So graphing the function, giving domain and range. Well, x has to be positive integers. You can't have any negative integers, which is why it's graphed in the first quadrant. I could have 0 cans. Could I have 1.5 cans? No. So can you tell me if this graph is going to be discrete or continuous? Right, this is a discrete graph. Even though we're going to have a general direction that's positive, 0 cans is going to be $4.75. 1 can is going to be $9.50, etc. You're not going to have 1.5 cans and the cost of that. So make sure when you graph a function that has a specific domain like positive integers, that you understand it's a discrete graph as well as having to be in the first quadrant. Okay, so now is the time in your notebook where you are going to, you can either print these out and write on them and answer the questions, or you can write them down individually, but you do have to write everything on this page in your notes, and then you're going to have to answer these 5 questions, and that's the last part of your note-taking for the evening. Thanks so much. Have a great night. See you tomorrow.